Hello everyone, welcome to SPEC eLearn, the online learning channel dedicated to chemical engineers. Fired heaters, types and applications. In this video course, you will learn basics of fired heaters, classification and types of fired heaters, application and selection of fired heaters, furnace draft, fired heater efficiency. Please subscribe to the channel. By subscribing, you will motivate us to produce more knowledgeable video content for you. Please subscribe now before you forget. This course will be presented in two-part series. In part 1, we will cover basics of fired heater, classification and types of fired heater. Part 2, we will continue with the remaining part of classification of and types of fired heaters, furnace draft, heater efficiency and burner selection. Fired heaters. What is a fired heater and what is its purpose? Fired heater is a direct fired heat exchanger that uses the hot combustion gases to raise the temperature of a process fluid flowing through the coils of tubes arranged inside the heater. The purpose of fired heater is to add heat to a process fluid. Heat is one of the most important things in the process plants. Fired heaters expose the hydrocarbons to heat that drives the distillation column, reactors, and in some cases, change the stream's molecular structure through cracking. Fired heaters are among the most complex pieces of process control equipment. Each furnace is at least two pieces of equipment in one. Firstly, it is a special variant of the shell and tube heat exchanger, since the purpose is to exchange heat. Secondly, it is a chemical reactor in which fuel and air undergo extremely exothermic reactions to produce the required heat. Depending on the use, these are called furnaces or process heaters. Process heaters. Heaters simply deliver the feed at a predetermined temperature to the next stage of the reaction process. Reaction furnace or a cracker. Heaters that perform reactions on the feed while it travels through the tubes. Which are the industries that use fired heaters? Fired heaters are used throughout hydrocarbon and chemical processing industries, such as refineries, gas plants, petrochemical plants, process plants, ammonia and fertilizer plants. Typical uses of fired heater in these industries include startup heater for preheating, process heater or regeneration air heater, cracking of feed hydrocarbon, and steam reforming. What are the principal modes of heat transfer in a fired heater? Radiation and convection are the two primary modes of heat transfer that occurs inside a fired heater. They occur in different areas of the heater, appropriately named as radiant section and convection section. The fired heater consists of Many important parts that are carefully designed for high temperature thermal duty. We will look at them one by one. A typical fired heater will have the following four sections: radiant section, shield section, convection section, breaching and stack. Illustrated in this figure is a typical fired heater highlighting the four individual sections we have just discussed. The combustion chamber is the radiation section. Note there is a toggle valve at the center of the firebox between the two burners. It is a vertical refractory brick exposed to the flame, mainly used in the delayed cracker unit. Now let me make you understand the individual sections in detail. First, the radiant section. The radiant tubes, either horizontal or vertical, are located along the walls in the radiant sections of the heater and receive a radiant heat directly from the burners or target wall. The radiant zone with its refractory lining is the costliest part of the heater, and most of the heat is gained in this section. This is also called the firebox. It absorbs 70 to 80% of the total heat duty of the fired heater. Heat absorption by radiation is 90% approximately. Balance is by convection. The next is convection section. The feed charge enters the coil inlet in the convection section where it is preheated before transferring to the radiant tubes. The convection section removes heat from the flue gas to preheat the contents of the tubes and significantly reduces the temperature of the flue gas exiting the stack. Usually consists of 3 to 6 rows. Roughly 20 to 30% of heat duty is absorbed in the convection section. Shield section. Just below the convection section is the shield or shock tube section containing rows of tubing which shield the convection tubes from the direct radiation heat. Typically have 1 or 2 rows of tubes just below the convection section. Several important measurements are normally made just below the sealed section. The bridge wall or break wall temperature is the temperature of the flue gas after the radiant heat is removed by the radiant tubes and before it hits the convection section. The next section is the stack and breaching section. The transition from the convection section to the stack is called breaching. This section collects the flue gas from the convection section and sends it to the stack. By the time the flue gas exits the stack, most of the heat should be recovered and the temperature is much less. Now come to the combustion process. Combustion needs a fuel. So what types of fuels are used in the fired heater? Typically, the fuels used for combustion in the fired heater include fuel gases such as natural gas and propane, liquid fuels such as naphtha and fuel oil, and off gases from refineries and plants. Before we move on to the classification of fired heater, let me make you understand the energy balance in a typical fired heater. This figure shows a schematic of a firebox radiant section for heat balance. The heat source is the fuel. Fuel is burnt with air. Steam is used for automation with certain types of fuels. The heat sink is a coil of tubes carrying the cold process fluid. The process fluid enters the firebox radiant section after preheating in the convection section of the heater and leaves at a higher temperature at the bottom of the firebox. The flue gas leaves the firebox for further heat recovery in the convection section. The firebox is refractory lined, yet there will be radiation losses from the outside wall. The heat balance in the radiant section. There are 4 primary sources of heat input to a radiant section and 3 sources of heat output from the radiant section. So we can write the heat balance for the radiant section now. QF plus QA plus QS plus Q fluid equals QT plus Q loss plus Q flue gas. Where QF is the sensible heat of fuel plus heat liberated by fuel, that is lower heating value. QA is the sensible heat of air. QS is the sensible heat of steam used for oil automation. Q fluid is the sensible heat of fluid. QT is the heat absorbed by the radiant tubes. Q flue gas is the heat of flue gases leaving the radiant section. Q loss is the heat loss through the furnace walls and bridge walls, etc. Note, if the sealed section is present, it should be accounted for also. The rate of heat transfer QT in watts from the combustion gases in the radiation chamber to the tubes carrying the process fluid called heat sink at mean metal temperature TW is expressed as follows. QT equals sigma into alpha times ACP times F times Tg to the power 4 minus Tw to the power 4 plus H into A times Tg minus Tw. Where alpha is the relative effectiveness factor of the tube bank. Sigma is a Stefan-Boltzmann constant. ACP is a cold pane area of the tube bank in meters squared. Tw and Tg are the tube metal and effective flue gas temperature respectively in degree Kelvin. F is the exchange factor or configuration factor. H is the convection coefficient between the flue gas and the process tube. A is the area of the process tube receiving the heat by convection in meters squared. Now let us come to the classification and types of fired heaters. As a critical piece of equipment in refineries and petrochemical and process plants, the fired heaters are designed in a variety of configurations to meet the unique requirements of each application. Broadly speaking, a fired heater may be classified according to the shape or the burner mounting or the type of firing. First, the fired heater classification by shape or orientation. Fired heater can be classified according to the shape into two categories: a vertical shape, that is cylindrical cross section; box shape, rectangular cross section. Vertical tube cylindrical heater. Vertical tube cylindrical heater is the most common type in the refineries. Typical heater has vertical tubes in the radiant section and horizontal tubes in the convection section. Shown in this figure is a vertical tube cylindrical heater with floor mounted burners. The top mounted stack provides a natural draft operation. This figure shows an installed vertical cylindrical design fired heater in a refinery. The radiant section has a floor mounted burners with vertical tubes arranged in a circle. The flue gas flows upward from the radiant section to the horizontal tube convection section. The advantage of vertical tube cylindrical heater is that it requires smallest plot area. Heat duty up to 40 million kilocalories per hour can be achieved with this heater. The radiant tubes in the firebox can be of helical coils also. This figure illustrates a vertical cylindrical heater with helical coil. This heater requires the smallest plot area. Small heat duties up to 15 million calories per hour can be achieved with this heater exclusively for startup heating purposes. Double-fired vertical tube box-type heater. Double-fired vertical box-type heaters consists of single vertical rows of radiant tubes arranged between rows of floor-mounted burners. This arrangement provides nearly uniform heating around the tube circumference. This figure shows the tube arrangement in a double-fired vertical box-type heater. This type of heater is used for applications such as hydrocracker charge heater, hydrotreater charge heater, pyrolysis, etc. The vertical tube design can be used in all non-folding services. Tube pull space is minimized as radiant tubes are pulled vertically upward. Shown in this figure is a double-fired vertical cylindrical box-type heater installed in a refinery. Horizontal tube box-type heaters. Horizontal box-type single shell or twin shell have horizontal tube layouts in both radiant and convection section. The radiant section tubes are arranged in a rectangular box-shaped enclosure with a convection section above or between the radiant sections. This figure illustrates the tube arrangements in a horizontal tube box-type heater. Observe, the horizontal tubes are laid on the side of the heater wall as well as on the roof. This figure is an example of horizontal tube box-type heater installed in refineries and petrochemical plants. Examples of applications include EDC cracking furnace in petrochemical plant, refining, atmospheric crude or bitumen distillation, vacuum distillation, visbreaker, hydrocracker, etc. For maintenance, the radiant tubes can be pulled out and replaced from the site easily one by one. Duties up to 20 to 125 million calories per hour can be achieved with this heater. It requires very large plot area. The tube being laid in horizontal axis, the arrangement needs a large number of coil supports. It is costlier than vertical type heater. Please subscribe to our channel and get updates on the upcoming courses by pressing the subscribe button. It will motivate us to produce free, knowledge-rich video content for you. With this, we have come to the end of the presentation. Please give your comments, if any, about this course after you finished viewing this video. Share with your friends and colleagues to reach out to large number of career-oriented professional students. Thank you for watching.